Hello students, I am Dr. Neeru Gupta with a series of lectures on nuclear physics. To begin with the nuclear physics, let's first of all go to the history of this. Somewhere in the 4th century BC, Greek philosopher, they were talking about the matter, and they said that matter is made up of indivisible, rather small particles which cannot be divided further. For next 2400 years, this theory continued, and after that, in the beginning of 19th century, the scientists who were doing experiments, scientists like Dalton, Avogadro, they introduced the concept of atom, and then after that, Mendeleev's periodic table, which we know is the basic thing, that was introduced. Then somewhere in 1896, radioactivity was introduced by Becquerel and then Curie. After that, somewhere in 1897, J.J. Thomson, he discovered electron, and after the discovery of electron, father of nuclear physics, Rutherford, he did the gold foil experiment and discovered nucleus. That means now there was a talk about an atom which is made up of nucleus, and around this nucleus the electrons are revolving. In 1932, Chadwick, he discovered neutron, and after that another science was there, that was of the elementary particles. That is, these particles are further made up of subparticles which are called elementary particles. This was the birth of nuclear physics. So after Chadwick discovered neutron, and it was there that atom is made up of central nucleus and electrons are revolving around it, and nucleus is made up of protons and neutrons. Here came the nuclear physics. There are certain terms which we will be using in nuclear physics, which is the charge, that is Z. If the two atoms, they have got same Z, they are called isotopes. If the two atoms, they have got same number of neutrons, which is N, they are called isotones. And if the two atoms, they have got same number of A, that is mass number, then they are called isobars. In studying the nucleus or nuclear physics, first of all, let's see what are the properties of nucleus. The properties of nucleus, when we talk about the distance in nuclear physics are measured in terms of Fermi. That is 10 raised to power minus 15 meters. This is the basic unit of the distance which is used in nuclear physics. When we talk about time scale, the nuclear reactions, they take place in the time scale of 10 raised to power minus 20 seconds up to thousands of years. So there is a large maximum possible range of time scale in the case of nuclear physics. When we talk about energies which are involved in the nuclear reactions or are possessed by the nuclei, it is measured in million electron volts. And the rest mass energy of nucleus is of the range of 1000 MeV. Then which approach is used, whether it is classical or we use the relativistic approach in the nucleus? Beta particles which are emitted from inside the nucleus, they move very fast, and the approach used for them is the relativistic approach. Otherwise, we do not use the relativistic approach. When we talk about nuclear mass, it is measured in atomic mass unit. We know that when we talk about the carbon atom, 12C, it has got the mass of 12 atomic mass unit. And this mass unit can be converted into MeVs. One atomic mass unit is approximately equal to 931 MeV of energy. When we start with the nuclear physics, let's see what are the forces which are present in this universe. There are 4 types of the forces. One is the first force, which we say is the gravitational force. Gravitational force, we all are familiar with the gravitational force. This is the force acting between any two masses present in this universe. Whether these two masses are this blackboard and this chalk, or blackboard and that stand, or two planets, or anything. So that means these gravitational forces, they have got very large range. They act in the whole universe. Then there are weak forces. These weak forces are there for the weak reactions which are occurring inside the nucleus. There are electromagnetic forces, which we say that they are acting between the charged particles, electric forces as well as magnetic forces, or we say the Coulomb's forces. The fourth type of forces which we will be studying, which we will be concentrating, are the nuclear forces. These nuclear forces are present inside the nucleus. When we talk about the strength of these forces, nuclear forces are the strongest forces in this universe. On the scale of 1, if nuclear forces we represent by the strength of nuclear forces we represent by 1, the electromagnetic forces, that is the Coulomb's forces, they have got the strength of the order of 10 raised to power minus 2. The weak forces, they have got the strength of the order of 10 raised to power minus 12. And gravitational forces, they have got the strength of the order of 10 raised to power minus 37. So if we compare the strength, we find that nuclear forces are the strongest forces present in the nature. Let's talk about the range. Nuclear forces are very short range forces. These forces are present only inside the nucleus. And when we have already talked about the size of the nucleus, that is the distance, it is of the order of 10 raised to power minus 15 meters. So that means the range of nuclear forces is only inside the nucleus of the order of 10 raised to power minus 15 meters. These forces are these are not shortest range forces. Remember, the shortest range forces are weak forces, which occur inside the nucleus between two nucleons when the weak interactions take place. So they are very short range forces, but of course these forces are the strongest forces. Then comes the nature of forces about attraction and repulsion. These forces are attractive up to the distance of 0.5 Fermi, and after that, when we take the distance lesser than 0.5 Fermi, they become repulsive. As we also know about the molecular forces, the graph goes same way. It is something like this. So up to 0.5 Fermi, they are attractive, and when the distance is decreased than 5.5 Fermi, they become repulsive. These forces, nuclear forces, are spin dependent. If two particles have got their spin parallel to each other, these forces are stronger than between the two particles which have got their spins anti-parallel to each other. So of course that means they are stronger in the triplet cases. Then comes the about their orientation. These nuclear forces are non-central forces. Generally we talk about the forces and we say they're central. That means they depend upon the distance or the line joining the two particles. Such forces are called the central forces. These forces are non-central forces. Non-central means they depend upon the orientation of the particles also. These forces nuclear forces are saturated in nature. When we talk about the saturated in nature, that means if we have got one nucleon, it is surrounded by the other nucleons inside the nucleus. These forces they are saturated, means they act only amongst the particles which are near to each other, only their surrounding particles. For example, in a classroom, if 30 students are sitting, we say student 1 is sitting in the center and rest of the students 1, 2, 3, 4, 5 like that. The force between first student and second student, if they sit like this, then the strength between this student can interact only with the second student. This student cannot interact with the 30th student. Same is the case for the nuclear forces. They are saturated. The two nucleons which are very near to each other, the nuclear forces are acting amongst them, and they are not acting amongst the particles which are far from each other. Nuclear forces are charge independent. We know that inside the nucleus we have got protons and neutrons. Two protons, they will have, obviously the two protons have got positive charge, and we say that if the Coulomb's forces are there, they will be repulsive. But nuclear forces, they do not depend upon charge. The forces between two protons are approximately equal to same as forces between two neutrons or force between a proton and neutron. These forces are of the exchange nature. When we talk about the exchange nature, That means they depend upon the exchange of the charge between two particles, exchange of the spin between two particles, and exchange of the coordinates of the two particles. After this, we say that for the very low energies, they depend upon the isotopic spin also. But for the high energy nucleons, they do not depend upon the isotopic spin. These are the different properties of the nuclear forces. Now we will be studying the nuclear forces in the first unit. In the next lecture, I will be concentrating on the nuclear forces. Now, how to study the nuclear forces? There are two types of the particles inside the nucleus. One is proton and second is neutron. The only stable particle or the only stable system which is existing of two nucleons is deuteron. Deuteron means nucleus of deuterium. It has got one proton and one neutron. That means if we study deuteron, we will be able to study the interaction between a proton and a neutron. So deuteron system is a really important system in the nuclear physics. Or if we study the scatterings, scattering of a proton from a proton, scattering of a neutron from a neutron, or scattering of a proton from a neutron, we will be able to study more of the properties of the nuclear forces. So in our next lectures, we will be studying the deuteron system. Thank you.